Hello?
Hello, is it better?
Yeah, it is better right now. Yeah, okay. Say something.
Hello, am I audible?
Yeah, it is better right now. It's still low, but it is better. At least I can hear you. So, okay. So, have you seen the plan that I have shared for maths for you? Have you seen the document I've shared on the group?
Yeah, the modules, right? Yeah.
Okay, so basically, I spoke to your dad yesterday, and like the exams that you're preparing for, this he had shared a syllabus, a rough syllabus for those exams, and the sequence of topics I have listed out. Okay, so first of all, you need to get the books that I have mentioned there at the end of the document. I hope your dad has seen it also, right?
Right.
So there are a couple of books by S.L. Loney. There is trigonometry, coordinate geometry books by S.L. Loney. Then there is the practice book. The third book, basically, which is Test of Mathematics at the 10 plus 2 level, is a problem book. It basically has questions from the ISI exams, one of the exams that you are trying to prepare for. Fourth book is a very good theory book, Higher Algebra by Holland Knight. And the fifth and sixth books are books on calculus and vector algebra by Shanti Narayan. It is used in most of the universities in India. So those are differential and integral calculus are two separate books by Shanti Narayan, and vector algebra is another separate book. So these books will more or less cover the syllabus that you need. Obviously, there are some parts of it which are not covered in these books. Some parts like number theory is not there. Uh, Complex numbers, probably I will use different resources for you. And statistics and mathematical reasoning is not there in these books, which I will cover separately. Okay. But
So,
roughly, these books will be enough for your preparation. Like 80-90% of your preparation will be done with from here. Do you understand what I'm saying?
right, and which book are we like starting with? So I like buy books one by one.
No, no, you need to get all of these books. We are not starting with any one of, don't have to buy them one by one. Like these are very cheap, very old classic books. You can get all of them together. You don't have to buy them one by one. You need to get all of them. Okay.
Okay,
So
got it.
these are very cheap books, and these are some of them are 100 years old. Thessalonian books are 100 plus years old, and Holland Knight Higher Algebra is 100 years old. The others are also very old books. The only new book here is Test of Mathematics at 10 plus 2 level. All of it you need to get, okay? You don't have to wait for them. The sequence in which we will be doing is in the module. The first thing that we'll start off with is module 1. We have already discussed basics of quadratic equations, but we have to go much deeper than what we have discussed so far. So module 1 has quadratic equations, polynomials, then we have a little bit of functions and graphs, then there is set theory, and then there is trigonometry and sequence and series. So obviously for the trigonometry section, you will need SL book. But that is the fifth thing that we are going to do. That's not immediate. Do you understand what I'm saying? This trigonometry part is after all of this we do. Okay. So
So
right
first,
now,
what are we doing?
uh-huh,
So first, what are we starting?
we are going to do this. The sequence of
Yeah, like
chapters is the same.
which book? No, like which book?
Right now, we are not following any book for quadratic equations. Once you have higher algebra and all, I will give you some assignments from there. But immediately, you don't have the books, no? So I cannot give you work from there. And any of these books, we are not going to do cover to cover. It's not like we have to do the whole book. We are going to do it topic wise, and we are going to do exercises and theory from some of these books that I will tell you what you have to do. It's not like we have to follow the book and we have to do it from the beginning first page to the last page. You understand what I'm saying? So basically, once you get higher algebra, I can give you some homework problems for some exercises you can do from for quadratic equations and for polynomials from higher algebra book. For sequence and series chapter also we'll be using this book. For trigonometry we'll be using SL Loni. For these two chapters, I will give you assignments that will not be from any one of these books, but will be something that I will share with you. But the point is that you have to follow the classes and do the work that is assigned. I will be sending you the assignments, or I will be mentioning which exercise you have to do from where. Is it clear? We'll definitely not be following your school book. That is not relevant for the preparation that you are trying to do. The exams that you are trying to appear for ISI, CMI, at least these two exams are far tougher than whatever you learned in school. So this is like much more ambitious. Preparation for that is much more detailed, and you need to have a different attitude. You need to have an attitude that you are going to learn problem solving and you are going to figure out everything in a nice way. Nothing about memorizing, nothing about I will just do it by this method or that method. You have to naturally learn how to solve problems, and that is what we need to train you for. It's not about what I need to know and I will not know anything else. Like the attitude has to be different. You have to learn to think in a problem solving manner, and you have to forget about what school had said and how you did stuff in school. How you prepare in school is totally different for how you have to prepare for these exams, because the subject is deep and the exams test your knowledge and understanding. They don't test memorization. Do you understand what I'm saying?
Yeah.
You have to say something.
Yeah, I'm saying, got it.
Yeah, so it's not about memorization at all. It's about ability to problem solve, and it's about like how much you love the subject. If you like the subject and you prepare for it properly, then automatically you will have good preparation for these exams. You don't have to actually focus on the exam so much. You have to focus on getting better at these things. It's about getting better at the subject rather than about worrying about the exams right now. So our first thing is quadratic equations. We have already done a little bit of the theory, but I had not discussed certain things because I thought we were preparing for your school stuff. So now that we have a different objective, we have to go into much greater detail about things. So first of all, I want to test whether you know some basic algebra. So do you know about algebraic identities? What identities have you learned so far? Have you learned any algebraic identities like a plus b whole square?
Yeah, okay, yeah.
What have you learned? What is this?
Yeah, these two, and then a plus b, a minus b, मतलब a square plus b square.
What is the a plus b whole square identity?
A square plus 2ab plus b square
And what is this one?
minus 2ab.
And what is this?
A square minus b square.
Okay, so these three are super basic identities. Do you know how to express a plus b or what is a plus b whole cube and a minus b whole cube?
I had done this, but like not memorized as such.
So
But I have
whatever
done this
identities I am writing right now, they need to be memorized. Like
now.
there is no way that you have to think about it. It should be so obvious that you don't have to think about it. So this identity is basically a cube plus b cube plus 3ab into a plus b. And this is a cube minus b cube minus 3ab into a minus b. You can multiply it and check whether it is coming or not. If you multiply and verify whether these identities are correct right now, do it. Verify whether 4 and 5 works or not. Are you able to see that it's coming?
Oh, we don't.
What?
know. Like, yeah.
You have to multiply and check whether it works out or not. So you have to find out a plus b whole cube on your own. And then you have to see whether it is equal to this. A plus b whole cube is the same thing as a plus b whole square multiplied by a plus b. A plus b whole square you should already know is this, right?
Yeah, it does.
If you multiply it with a plus b, you have to see whether the terms are matching or not, right?
Yeah.
Again, identity 4 and 5, you need to write down in your notebook and you need to remember it. And from now on, for our classes, you need to have a separate notebook where you make notes during the class about what you're learning. That separate notebook, by the way, that notebook is only for class discussion and theory. That notebook that you are doing, whatever you're doing right now in whichever notebook, it's only for the class discussion and theory. You're not going to solve your homework in that notebook. There will be a separate notebook for homework and practice. Do you understand what I'm saying? You have to maintain two separate books. One book is for class, what you learn in class. It just has the discussion that was done in class. By the way, when we do a discussion in class, you don't have to write down everything. Like everything I said doesn't have to be copied down. Do you understand? What do you have to write down according to you?
They do not. I mean, I wrote this all the identities down.
The identities you have to write down. But suppose you were doing a problem and you don't have to write down everything that I do. What you have to write down is anything new that you didn't know. Anything new or the idea behind the solution in your own words. Suppose we are discussing a problem. You have to write the problem and maybe try whatever we have done. Suppose you didn't get the problem and I showed you how to solve it. Then the idea behind the solution has to be there in your notebook. Why is it important to write down the idea behind the solution? See, when I say the idea behind the solution, I don't mean write down all the steps of the solution that I showed and then not write anything else. Do you understand what I'm saying right now?
Yeah, so like if like I'll be able to solve something with a similar concept.
So the
That's
point is that many times what happens is that even if you have a solution, after 3 weeks, what will happen is when you read the solution, you might forget why it is happening. Why did he do this? Why is it this way? And you might not understand it. It happens many times. Might not understand why I did something. And it doesn't mean that you have not written down the steps. You might have written down all the steps, but you still can't understand the solution 3 weeks later or 1 month later. And that is a very common occurrence. That's why students can't understand the books because they don't know the why, they don't know the ideas. They are just copying the steps. Do you understand what I'm saying right now?
got it.
So I don't want you to make notes like just write down everything that I did and that's enough. You need to write down the explanation. The explanation should be in the notes. Even if you miss some step, it is okay as long as the explanation is clearly mentioned in your notebook. The point of maintaining notes is that 3 months later, when you read it, you should be able to understand what is going on. Do you understand?
Okay.
If your notebook is not doing that for you, then there is no point in making notes. If 2 months later you can't understand what happened, then there is no point to making notes. Okay. So the main thing is when we are discussing something, you need to not just write down the facts. The main thing is even if you miss some facts, don't miss out the key ideas or the explanation. The understanding is what you have to capture, not the steps, mechanical steps that I have written. I hope it is clear what I'm asking.
Yes.
So that class notebook has to have all that. It should have the discussion that we did, any new thing that you learned. If we did a problem, and if we did a discussion of a problem, then the key idea that helped us solve that problem should be clearly mentioned. It should not be that it is hidden and you have to struggle to understand it later. So that is one thing. And do all your practice work or homework. The practice or homework can be done in another book. Another book. Don't don't use the class notebook for your practice work. The class notebook should be like, okay, class 1, date 14th May. This was what we did. And this is what we learned. Then the next class should have, okay, 17th May, this is what we did, this is what we learned. It should not have anything else. Is it clear what I'm saying?
Yeah.
Okay, so those are basic hygiene things which you have to maintain. Then only the preparation can happen well. Other than that, like I will tell you what you have to do, what homework will be assigned and all. So that should not be a problem. Okay, let's get back to algebra. So we have our basic identities for a plus b whole square, a minus b whole square, a square minus b square factorization is a plus b into a minus b. We also have 4 and 5, which is a plus b whole cube is a cube plus b cube plus 3ab times a plus b. And 5 is a minus b whole cube, which is a cube minus b cube minus 3ab times a minus b. These two have to be remembered. You cannot be like, I will forget it and later I will figure it out. Then there are two more very useful identities, which is a cube plus b cube. This is the factorization of a cube plus b cube, and also another one which is a cube minus b cube. So these are factorization identities. And you might have seen it in ninth grade also. I don't know if you have seen it, but in ninth grade CBSE, people learn it. So are you aware of a way to factorize this? Sum of cubes. Do you know the meaning of the word factorization?
Simplify.
What is factorization? Tell me.
Simplify maybe.
No. Factorization is not simplification. Factorization is writing an expression as a product of one or of two or more factors. As a product of two or more factors. Do you know that what is a factor? Any number, do you know that it has factors? Any number
Yeah.
can be broken down into smaller numbers, which are sometimes called divisors or factors.
Yeah. Yeah.
Any number can be broken down into prime numbers, which are prime factors of the number, right?
Right.
Just like that, algebraic expressions also sometimes can be written in terms of multiplication of simpler expressions. Those simpler expressions are called factors of the original expression. For example, here a square minus b square has been written as what? The multiplication of these two expressions, right? Do you understand what I'm saying, right?
Yeah.
So we can say that a plus b is a factor of a square minus b square, because you are writing a square minus b square in terms of a plus b times something. Correct?
Right.
Similarly, a minus b is also a factor of a square minus b square, because you are writing a square minus b square as a plus b times a minus b. Both of these are factors of this expression. Correct?
Okay.
So what I mean is I want to write a cube plus b cube as I want to factorize a cube plus b cube. When I say factorize, what it means is write it as a product of something times something. That's what we need, right? Do you understand now what is the job?
Yeah.
Notice that the other formulas that we had, a plus b whole square is equal to a square plus 2ab plus b square. This is not a factorization. You're just simplifying and writing it as a three terms, right? This is an addition of three terms, right?
Yeah.
It is not a factorization formula. It is an addition. It's a simplification of this, right?
So factorization is basically breaking down into
Yes.
two.
Product of other expressions. You have to write a cube plus b cube in such a way that you can write it as a product of multiple other expressions, right?
Right.
So what we will do here is we'll use this identity, and we just now saw that a plus b whole cube was what? A cube plus b cube plus 3ab times a plus b, right?
Right.
So from here, we can isolate a cube plus b cube, because that's what we are trying to factorize, right? We can say a cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b. Correct?
Yeah.
And now, when I have this term minus this term, you can easily see that a plus b is a common factor, right? Between this term and this term, a plus b is present in both the terms, right?
Yeah.
Actually, here there is a plus b whole cube. Three of them are present. And here only one
Yeah.
a plus b is present, correct?
Correct.
However, so we can definitely take a plus b common.
As common.
And
Yeah.
what we'll be left with is here, it will be
Is
a
a
plus
plus
b
b
whole
whole
square
square
minus 3ab.
minus 3ab. Yeah.
And now I'll simplify this using our basic a plus b whole square identity. And I will get a plus b common. And inside I will get what? A square plus 2ab plus b square minus 3ab, right? Do you understand that we are ending up with this?
Wait, why did we subtract 3ab a plus b square? Oh, no, a plus b, yeah. Why did we subtract that?
It is obvious. You have to figure it out yourself. All the steps are clearly on the board. See what I have written. It should be obvious.
Okay, my bad. Sorry.
Is it obvious? Why we subtract?
Yeah, my bad.
We have taken a plus b common. We are left with this minus 3ab. Can we simplify it and write it as this?
Yeah.
That gives us our identity. A cube plus b cube is a plus b times a square minus ab plus b square. Do you understand? We have just now done the proof of it. We have proved that it is correct. What we did was we used this expression and isolated a cube plus b cube and took a plus b common. And as soon as you do that, the inside thing will simplify to become this only, right? Did you understand how it has come?
Yes.
Find the factorization for a cube minus b cube now. You have to follow almost exactly the same method with slight differences because it is a cube minus b cube now. Which formula should we use to get this?
Very what?
Which formula should we use to get this?
A minus b whole cube.
Right. A minus b whole cube was what? A cube minus b cube minus 3ab times a minus b, right? So from there, I need to isolate this part of it, right?
Right.
So I will take the other stuff and put it on the other side and keep this one as it is, right? I can write it as a minus b whole cube plus 3ab times a minus b, correct? And then what can I take common between these two?
A minus
A minus b common, what will be left here is a minus b whole square plus a 3ab, right? I hope it is clear what we are doing. What does this become now?
A minus B, then bracket A square minus, sorry, plus AB plus
Hmm.
B square.
Right. So that is our seventh identity. Again, this is something that has to be remembered. These two are very useful, okay? Like we have just done the derivation, but you don't have time to do the derivation when you have a real problem. You need to remember it directly, okay? So make a note of it, understand the derivation and try to remember it because it will be used many times. Now, notice one thing. We have a square minus b square is a minus b into a plus b. We have a cube minus b cube is a minus b into a square plus ab plus b square. Now let's find out what is a power 4 minus b power 4. So what I will do is I will show you how to factorize it. Okay. So we are trying to factorize this expression. So we are going to write it as, can you think of it as a square square minus b square square? So then by using the a square minus b square identity, we can write it as a square minus b square times a square plus b square, right?
Right.
And now this part itself can be written as a minus b times a plus b, and this is untouched. It can be written as it is, right?
Okay.
Do you understand what I have done here?
Yeah.
I have split this one into two terms, and this one can't be split because it's a square plus b square. Now, if I want, what I can do is keep a minus b as it is and multiply this one and this one. I'm multiplying it right now just to show you something. You don't need to do it. It's already factorized. But I'm multiplying it right now just because I need to show you something. So let's multiply this term and this term. So see what will come. A cube plus ab square plus ba square plus b cube, right? Do you understand what I've gotten?
Yeah.
So I will rewrite it in a nice order. I will write it like this. A cube plus a square b plus ab square plus b cube. So that is equal to a power 4 minus b power 4, no?
Okay.
So I'm getting this expression. A power 4 minus b power 4 is a minus b, a power 3 plus a square b plus ab square plus b cube. Do you see a nice pattern here, at least in these terms? Do you see some nice things here?
A common maybe.
No, we don't have to do any more simplifications. I'm saying, can you notice a pattern to the terms? Is there some regularity or some pattern in the terms that are coming?
Think, yeah, like it's how we have a square plus ab plus b square, similarly a cube plus, so
So
on.
first of all, notice that the first term starts with a power 3. Then second term has a square and b power 1, right? And third term has a power 1 and b square, right?
Okay, yeah.
And fourth term has b power 3. So can you see that a powers decrease and b powers increase?
Right.
Do you notice that now?
Yeah.
And notice that each term, the power here is 3 and the power here is 2 and power here is 1. So the power here is also 2 plus 1, 3, right? And the power here is also 1 plus 2, 3, right? Do you notice that all terms have the same degree 3?
Right.
Do you understand so far what I'm saying, the patterns that I'm telling?
Yeah, got it.
Notice that we started out with simplifying a power 4 minus b power 4. And in this big bracket, every term had degree 1 less than this 4, right? 3, right?
Yeah,
Correct? Notice also that when it was a cube minus b cube,
it
the
was
in the
square.
big bracket, the terms had degree 2 because a square, then a power 1, b power 1, and then b square, right?
Right.
And when it was a square minus b square, here the terms had degree 1, right?
Yeah,
So this is like a general pattern, and always notice that whenever there is a square minus b square or a cube minus b cube or a power 4 minus b power 4, a minus b is always a factor, right?
okay.
Correct?
Yeah,
So all of this can help us make a general statement, and then we will see examples of why that statement is true. Okay, so my general statement is like this. If it is a power n minus b power n, I am trying to tell you a general factorization for a power n minus b power n, right? N could be bigger than 4 also now. Is it clear what we are trying to achieve?
yeah.
I am going to say that whenever it's like this, a minus b is always a factor, right?
When it's a raised to n minus 1.
A raised to n minus 1, it will start off with, and after that, powers of a will decrease and powers of b will increase, right?
Yeah,
It will be a raised to n minus 2, b power 1. Then it will be a raised to n minus 3, b power 2, right? And so on
right.
till a power 1, b raised to n minus 2, till b raised to n minus 1, right?
Yeah,
That's the pattern that we have seen so far, no?
right.
So this is an identity, by the way. This is an identity which is true. There are ways to prove it, but for now, I don't want to worry about the proof of it. I just want to see whether it works for some simple cases. Like let's check whether it is true for a power 6 minus b power 6, right? Do you understand what we are trying to do right now?
Yeah,
So a power 6 minus b power 6, can we write it as a square whole cube minus b square whole cube?
yeah,
And
yeah.
now we have something cube minus something cube. We should apply this identity, no, right?
We could apply a square minus b square also, right?
We can
Like
do that
same thing.
also, but it will be faster with this. That's why I'm doing this.
Okay.
Do you understand what I'm saying? We can
Yeah.
apply that one also. It's correct. But we can definitely apply the second one, right? Something cube minus something cube, right?
Okay.
So what will come here? What should I write? Tell me. Applying the second identity. What should I write?
A square minus b square bracket, then a raised to 4,
Mhm.
plus a raised,
Yes. This is what will come, right?
right.
And now what we can do is this a square minus b square I can split as a minus b and a plus b. And then I have left off a power 4 plus a square b square plus b power 4, right? Correct?
Right.
And now I can keep a minus b untouched and try to multiply the remaining two to get whatever comes, right? The big expression that should come, right? I'm multiplying these two because I want to prove this identity is correct. No, so I need only two factors here. I don't need three factors, right? I hope you're understanding what I'm saying.
Yeah.
So if I just multiply this one and this one, then let's see what comes. A power 5 plus a cube b square plus a b power 4 plus b a power 4 plus a square b cube plus b power 5, right? I hope you are getting, I'm just multiplying this and I'm writing all the terms, right?
Right.
So let's simplify that a little bit and write it in a proper way. It is a minus b times. Proper way means starting with the powers of a being large and then slowly powers of a should go down, right? A power 5. Notice that this is a power 4 into b, right? Then this is a cube b square, right? Then this is a square b cube plus there is a b power 4 plus there is a b power 5. Do you get this expression? Is it coming for you also? I hope you're understanding so far what I'm trying to tell you.
Yeah.
So now can you say that we have proved this identity for n is equal to 6? This is what would have come if you put n is 6, no? See? You put n is
Right.
6 here, this is what will come, right?
Yeah.
So basically that shows us that our identity is working. One second. Our identity is working and our general identity is a power n minus b power n is equal to a minus b, a power n minus 1 plus a power n minus 2 b power 1, a power n minus 3 b power 2, and so on till a power 1 b power n minus 2 plus b power n minus 1. I hope the pattern is clear to you.
Yeah.
So you should write this down also as one of the identities that you should know. Okay. So in general, this will help us find quickly what is the factorization of something like a power 7 minus b power 7, which would otherwise have been really difficult to do. I hope you appreciate that it is not very easy to factorize this. Correct?
Right.
Now that we know these basic identities, I will show you another one which is super important. Okay, this is something that you might have seen before. I don't know if you have learned about it before or not. Tell me if you have seen this before. Have you learned how to factorize this expression? No. You have to say yes or no.
Hello.
Yeah.
I said no.
Okay. So this is a plus b plus c multiplied by a square plus b square plus c square minus ab minus bc minus ca. So this is a very important identity. It has to be remembered. Right now, I cannot show you the proof of it, the nice proof of it. So basically, there is a nice proof that uses polynomials and equations, theory of equations. But for now, you can easily verify it by multiplying it, right? 1 second, just. Okay, so here you can multiply it and verify. I don't want you to do it right now, but it will come, okay? This is a correct identity. You can also check it by putting some simple values of A, B, and C. For example, if I put this, but let's not put B as 0. Let's put B as 3. You can verify what is LHS right now, no? Do you understand what I'm trying to tell you, how to check it?
Yeah.
We can easily verify LHS right now. It is basically 1 plus 27 plus 8 minus 3 into 1 into 3 into 2, right? So this is 18. So this is basically 28 minus 18. So 10 plus 8. So answer is 18 on the LHS, right?
Yeah.
And now let's check the RHS. 1 plus 3 plus 2. That is 6, right?
Yeah.
And this is 1 plus 9 plus 4 minus 1 into, so 3 minus 6 minus 2. Correct? And notice that this is becoming 3 here. So it is 6 into 3, 18 also. Correct?
Right.
So this is just a fast way to verify whether it's correct or not. You can take any number values and you will always get that it is right. Or you can multiply it out and see whether it comes or not. Okay?
Yeah, but that's like a long process.
Yeah, that's a long method, but there is a nicer way to prove it. But right now I can't show you because you don't know enough polynomials and theory of equations. So we will not do it right now, the proof. But you need to know this identity because many times you will have situations where this identity becomes useful. First of all, what I will do is I will also show you a different version of this expression. This expression can be written as half into 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. Do you understand that this operation has not changed anything?
Yeah. Got it.
Now, why did I do that? Because now I'm able to write it like this. 2a square and 2b square. Out of that, I can take 1a square and 1b square and combine it with minus 2ab, right?
Yeah.
Then I have what? I have 1a square left, 1b square left, and 2c squares left, right? Correct?
Right.
So I will take 1b square, 1c square, and combine it with 2bc. Now I have 1c square left and 1a square left, which I will combine together with 2ca. Do you see that the same thing can be written as groups of 3 like this?
Is there a, okay. Okay. Okay.
Do you understand what I'm saying so far?
Yeah.
So what have I done? I have done half and made 2 inside every term here, right? And then the 2a square, 2b square, 2c square, we have combined taking a square plus b square here, b square plus c square here, and c square plus a square here. And the 2ab, 2bc, 2ca are coming in with them, right?
Right.
The reason this is good is because each of them is a square of something, a minus b whole square plus b minus c whole square plus c minus a whole square, right?
Yeah.
And now we have another version basically of the same thing. We can write it as half times a plus b plus c. And then inside you can write a minus b whole square plus b minus c whole square plus c minus a whole square, right?
Right.
Why is it important? Because whenever there is a square of something, it is always positive. So we are guaranteed that when you have the sum of 3 squares, it will always be greater than equal to 0, right? The second term, right?
Yeah.
This second term can never be equal to 0 unless all three are equal. A is equal to B is equal to C. Then this and this and this, all of them are 0, right? Correct.
Yeah.
So I'll write it in the next page and I will tell you all the consequences of this. So I'm writing it like this first. This was the original expression. And then we wrote an alternative expression with a half. And now I have inside, I have a minus b whole square, b minus c whole square, and c minus a whole square, right? This is an alternative version of the same thing, right?
Yeah.
Now, what I want you to realize is if a is equal to b is equal to c, then a minus b whole square plus b minus c whole square plus c minus a whole square is equal to 0, right? And therefore, LHS is equal to RHS is equal to 0 happens. Correct?
Right.
This is the LHS. And these two are the two versions of the RHS. Correct?
Right.
Second thing that you should remember here is if A plus B plus C is 0, right? Then can you say that clearly RHS is 0?
Yeah.
And if RHS is 0, that means LHS is also 0, which means A cube plus B cube plus C cube minus 3ABC must be 0, right? Correct?
Yeah.
Which
Yeah.
finally we say that this means that A cube plus B cube plus C cube must be equal to 3ABC. Notice that this is not always true. It is true only when A plus B plus C is 0. This is what we call sometimes as a conditional identity. So what is the condition? That A plus B plus C is 0. And in that condition, A cube plus B cube plus C cube is equal to 3ABC. Do you understand the reason why it is happening?
Yeah.
Because A plus B plus C is equal to 0 makes the RHS 0. And since RHS is equal to LHS, LHS is also 0. And from there we get this condition. Correct?
Yeah.
So you need to write down this identity and the two cases that I have shown you. The two conditions, the two things that we have just now discussed. These will come in handy many times in your algebra. Okay.
Right.
If you have copied down, then we can continue ahead.
Yeah. I have.
Okay. Fine. So the next thing is now learning how to apply all of the 8, 9 identities that we have seen and learning how to apply it in problems. So this is the interesting part and the challenging part. Now, your job is to factorize the following expressions. When I say factorize, I hope you know what I mean. Do you know what I mean when I say factorize?
Yeah. Product of
Uh,
two expressions.
two or more, it can be more than two also, right?
Or more. Yeah.
You have to write it somehow as a product of multiple algebraic expressions.
Got it. We do it now or this is homework?
Now,
Okay.
this is classwork. Homework I'll send by tonight or tomorrow morning latest. These five expressions, we want to factorize them. Tell me if you are stuck in the first one or if you're trying what you're trying in.
Give me a minute.
What?
Give me a minute, I'm trying.
Yeah. Any luck with first one? Any progress?
Can we, so what I am doing, like I'm not done yet. So,
Hmm.
I considered x square as z
Hmm.
and like suppose let's say
Y
w
square as
as
W.
y square. Yeah, and then solving as a square plus minus 2ab plus a square.
So what are you getting? Are you getting something? The problem is
Yes.
you realize what to do about the 3, right?
Yeah,
So actually it is easy only. You just have to split the 3. For example, you can write it like this and 1 x square y square is outside, right? Do you understand what I have done here?
okay. Yeah.
We have just split the 3 into 2 of them here and 1 of them here, right?
How do you know, like, when do we like split? When do we consider it
By
as like
practicing many
Z?
questions. In my childhood, I have done many factorizations. That's how I know. By experience, you will know. There is no shortcut or there is no magical way. Okay. By doing many questions, you will know. If this is the first time you're seeing it, then obviously it will be new for you. But after 1 or 2 times, it should become like, oh, this is something that we can do. Do you understand what I'm saying? There is no one way to predict what has to be done. Okay. It's all about being smart about it and trying out different things. Notice that you have already noticed that this can be a perfect square, right?
Yeah,
So this is clearly x square minus y square whole square, right?
yeah,
And what is this? This is minus xy whole square,
yeah.
correct? Isn't that good? Because now we have a square minus b
O
square,
minus b square.
where a
Yeah,
is this and b is this, right? So
yeah,
basically that helps us factorize it because now I can say it is a minus b into a plus b. But what was my a? It was x squared minus y squared. What was my b? It was xy, right?
yeah.
And a plus b would be x squared minus y squared plus xy. Do you understand? Notice that our question is done because now we have factorized it, no? This is the process of factorization. All we did was split this middle term in order to make both of them squares and the whole thing as a difference of two squares. I hope it is clear what we have done. Once you get it as a difference of two squares, you are able to factorize it as a minus b, a plus b, and you put back the x and y instead of a and b, and you will get this factorization.
Right.
Right. So now that we have seen one example of it, now you have to think similarly and try to figure out question 2, question 3, and so on. Try to do question 2. You have to think creatively and use the identities we have discussed in today's class. Nothing beyond today's class identities are required. Okay. All of the identities that you have written down in your notebooks, nothing beyond that will ever be required. So that only you have to use.
Do I answer like one by one or like all of them?
No, tell me if you factorize second one.
Oh, I think I did.
How?
So,
Tell me.
so first, like the first part of the thing expression is a square minus b square. So x square minus y square minus 4y minus 4.
Hmm.
Then we can make it x square minus
Hmm.
bracket y square plus 4y plus 4. So
Right.
x square minus
Y
y
plus
plus
2
2
whole
whole
square.
square.
And then we can
And
write
then
it
it's
as
just,
this and this.
yeah,
So this is the factorization. Basically, we are
yeah,
using finally the same identity. We are saying a minus b into a plus b, right?
yeah.
Okay, so second one is done. So again, here nobody told you that you have to group these last three terms together, but that's what it involves. Like you have to figure out what to do in a particular question. There is no rule, like we cannot give a general rule for it, right?
Right.
Do you understand what I'm saying?
Yeah.
You have to figure it out in the question. According to the question, the method might be different.
I'm stuck in this question.
Okay, when I tell you how it comes, you will be like, okay, I should have gotten this. See, expand it. This is what is coming, no?
Yeah.
And now just group the first term, second term, and last term together. think about it, this is 2x whole square plus 2 into 2x into 1 plus 1 square, right?
Can we think about it this way? Like, can we think 4x square minus 4y square? So 2x plus 2y bracket 2x minus 2y that way.
You can, but that doesn't help you factorize it because you will be stuck with the what to do about the remaining, right?
Yeah,
Do you understand? That's not a complete factorization because you
yeah,
are
that
stuck with
was
this stuff.
parallelist.
So it's okay for the first two terms, but what do you do about this? That's not a full factorization. No? So that's why you have to take a different approach because that approach doesn't give us a full factorization. Right now, what I have done, can you see that it's the first term is 2x plus 1 whole square?
Yeah,
And now it is obvious because this is what? 2y whole square.
yeah,
And now I'll just do the same identity 2x plus 2y plus 1 and 2x minus 2y plus 1. Do you understand? It's just a different grouping, and you have to notice that this is actually a perfect square of 2x plus 1. Correct?
right.
As soon as you notice it, it is over. It's the same methods that we have been doing for the first two. I hope it is clear.
Yeah.
Okay, fourth one then. You should expand the terms in the fourth one. You will get x square minus 4xy plus 4y square minus 4, right?
Right.
Can you spot a perfect square here?
Y, yeah, 4y square minus 4 or x square minus 4. Both work, right?
No, what I mean is, can you see if a plus b whole square and a minus b whole square, any terms can be written as this?
Um, is there any?
Yes, there is.
Oh, no. What? Yeah, okay. Yeah, the first three. Yeah.
Yes. You have to be able to spot that it is 2 into 2y into x plus 2y whole square, right?
Yeah. So x minus 2y whole square
Now it is done
minus
because this
4.
is 2 square, right?
Yeah,
So now you can say x minus 2y plus 2 multiplied by x minus 2y minus 2. Correct?
right.
Do you understand how we are spotting things and then getting the factorization?
Yeah.
So this is the kind of thing that you have to be clever about, and it will come only with practice and experience. Okay. It will not come by hoping that it comes. You have to do many questions, then only it will be not normal for you. Do you understand
Yeah.
what I'm saying?
Yeah.
So what I will be doing is I will be sharing a small
I didn't
assignment.
copy the last question.
Okay. Just copy the last one. Uh,
Yeah. Go ahead.
I'll be sharing a small assignment for you, which will be on topics that we have covered today. So I'll share it by
Right.
tomorrow latest. It will be put on the group. Okay. So that will be about factorization only. And
When
you
is
should
our
try
next
that
class?
Saturday. Classes are Wednesday and Saturday evenings. Wednesday and Saturday is the timing. So you have 1 or 2 days for it, and you should try it out till then. Okay.
Got it.
I will send the assignment by tomorrow morning for sure. So uh, make sure that you do that in a separate notebook. Do the homework in a separate notebook. You can use this notebook for the stuff that you learn, new identities that you learned, ideas that you have seen in class, and use that while solving the questions. Okay.
Right. Also, do we need the textbooks immediately?
You don't need it immediately, but
Yeah.
we will need it sometime, like soon. But
Yeah.
like right now, we
Right.
don't need it immediately because right now we are following a slightly different book. We are following a different order. Once we do a little bit of this basic algebra, we will come back to quadratic equations and go a little deeper on it and see what we can learn there. Like we have to do it in a different way, not the way you have done it in school. So we have to basically learn how to solve problems, and we'll try to see as many different types of problems as possible. Our job is to become very comfortable with problem solving. That's the main thing. Okay. So you have to be prepared to like sometimes struggle with problems. It's okay that you don't get a problem in the first attempt. Having difficulties with problem is not an issue as long as you give it a fair try. If you don't try the question and look at the solution or hope for some easy way out, that will be difficult. That is the bad thing. That is what you have to avoid. Do you understand what I'm saying? It is okay to not be able to do a problem, but it is not okay to have not tried it at all. Even if it looks difficult, you have to try it and you have to give your best. It is only by trying to solve problems can you learn. Do you understand?
Yeah.
This is not like school. Memorization and all won't work. You have to be creative. You have to learn how to think differently, think according to the problem, and have a lot of patience. Many times it will take 10 minutes, 15 minutes, 20 minutes maybe to solve a problem. Don't expect that every question will be solved in 2, 3 minutes. Okay. So you have to get rid of those expectations or get rid of the hope that everything will be easy. It will not be easy, and things are usually more challenging, and then only people learn. When you struggle with a question and you try it multiple times and later you figure it out, then that is how you learn. And that is what you have to be prepared for. I hope you understand the attitude is super important while preparing for these exams. The way you prepare is super important. Knowledge and information can be gained, but if you have the wrong attitude towards problem solving, it will be difficult to fix that. Do you understand what I'm saying right now?
Yeah, could you please show the last question, like how to do it last?
Last question is in which one?
The one you had written.
Which question? Fifth one.
Yeah,
Why? You should try it, no?
able to do it.
You have not yet tried it, right?
No, I was doing it.
But that's what I'm saying. This is, see, this is an example of what I'm just saying. First thing, you should be listening to what I'm saying rather than doing something else. That's the first thing. When were you doing the problem? When I was giving you like a gyan on how to worry about the preparation, you were actually doing the question. Huh?
I was listening. I just started.
That's not how it that's not how it works, dude. When I'm giving these long lectures, it's not for you to completely ignore it and do something else. Do you understand what I'm saying, right?
Right.
Like if you
Sorry.
completely zone out and start doing problems instead, then who am I giving these lectures for? I have heard myself many times before. I don't need to listen to it again. I'm giving these lectures for your benefit. These motivational speeches, you think it comes very easily to me? It's not easy. You have to come up with these impromptu speeches and all. You understand what I'm saying right now?
Yeah,
These are
sorry.
for you to listen to. And you are calmly doing a question right now. It's funny, but like you have to listen to what. Did you listen to anything I said?
I did.
Okay. So, one of the things I said in my lecture was that you have to have a little bit of patience with yourself and not look for an easy way out, which is what you are doing right now by asking me the solution. Do you think 1 or 2 minutes of doing the problem is enough and you can already lay down your weapons and surrender to this question? I don't think it is enough, and I think you have the ability to solve it. You are just giving up really fast. I hope you understand what I'm saying right now.
Yeah.
See, the point is you don't have to give up so quickly, and the questions that I will be sharing will also be challenging, and you will have to expend your energy a little bit. You can't give up in 2 minutes, okay? If you give up as soon as you look at a problem and the first idea that comes into your head is not working, that doesn't mean that now we surrender.
Yeah.
You have to try some other things, try a little bit. 15 minutes is fine. If you spend 10-15 minutes solving a problem, it's fine. If after 15 minutes and multiple attempts you can't do it, then you can leave it. But I'm not going to tell you the solution if you have tried for a brief 2-3 minutes. And that is not what you should expect from yourself also. Nobody gets these questions in the first attempt or the first couple of minutes. So that's how what we will be doing is different from school. In school, there is hardly anything you have to think. You have to do the first thing that comes into your head or what has been taught, and that's it. But we are not preparing for school exams, right? What we are trying to do is far tougher, and what we have to do, therefore, is that attitude of problem solving, of not giving up, and not looking for an easy way out. Do you understand? You need to show a proper attempt before we do the solution, okay? I hope it is clear.
Yeah.
So try it a little more and I will share the assignment. Try those also. Basically, what I'm saying is this is like a new journey. It's an exciting and wonderful journey when you learn all of this maths. It's, however, not going to be easy. And you have to mentally prepare yourself that it's going to be challenging and it will stretch your limits. And that's how people learn anything. If all we did was easy questions, then nothing is being learned. Okay, fine. That's all for now. We'll continue on Saturday. I'll be sharing the assignment by tomorrow. Okay. Do you have any questions that you have to ask? Anything that you need to ask or clarify or anything? Okay. If there is nothing, then we'll continue on Saturday evening. Okay.
Yeah. Yeah.
Fine. Okay. Bye.
Bye, sir.
Mhm.